The diagram shows a hexagonal prism. Write down the number of edges. Any line, curved or straight, along which two faces meet is an edge of the solid. Let us count the number of them. We are counting the number of edges. Any line along which two faces meet. There is no curved line at the moment. All of the lines are straight. Any line along which two faces meet, and we are counting those edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 edges. We next need to count the number of vertices. We may identify and count them quite easily because a vertex is any of those pointed locations. A vertex is any of those pointed locations. Let us count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. Notice that we are not using our counter on this occasion. We may use it when we are making our final decision on the number of vertices that we have, and that is after we have clarified what vertices really are. However, we need to explain what we mean by vertex of a three-dimensional figure, and we will begin by looking at the vertex of two-dimensional figures. We need to take a look at what we really mean by the vertex of a three-dimensional figure, and we will begin with the two-dimensional figure. So we have some two-dimensional figures right there. A vertex of a plane figure is a point on it where two sides meet. Anywhere two sides meet, that's a vertex. Same for the triangle. Any point where two sides meet, that's a vertex. And it will be the same for this figure that we have right here, which is a pentagon. A vertex is any point where two sides meet. Three-dimensional figure. A vertex of a solid is usually defined as a point on the solid where two or more edges meet. Right there, where two or more edges meet. This is one edge. Here's another edge. There's another. All three edges meet right here. Therefore, this point is a vertex of this solid, which we know to be a cuboid or a rectangular prism. It is also true that any vertex of a solid is also a vertex of one of the faces of the solid. If we have a solid, and the solid of course will have faces, any vertex of a face of the solid is also a vertex of the solid. Now, here is our face of the solid. And notice that here is a vertex of the face. And the vertex of this face is also a vertex of the solid. A vertex of the solid may also be a common vertex of a number of faces. So there is the vertex, and we are saying that that vertex is a common vertex of all of these faces. This face, and this face. So a vertex of the solid is a common vertex of faces of the solid. So here we have the three faces in their three different colors. The vertex that we have here is a vertex of each of these faces. A vertex of a solid may also be a common vertex of a number of faces. The diagram shows a hexagonal prism. We are going back to our original diagram, of which we need to write down the number of vertices. Now that we have all of the clarification on what vertex is, we may go straight ahead and count the number of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So right there we have 12 vertices of the hexagonal prism. There are 12 of them.
For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.